Great seeing you here again. My name is Ludwig Koster, founder of the Koster Academy, and welcome to this new video of the Math Survival Guide. We're talking again about trigonometry, and here in this video I will define the basic trigonometric functions cosine and sine. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's start with this new video. We start with defining the sinus and cosine of an angle. So when we have this graph here, we can see that we look at two elements, x1 and y1, which are in fact the coordinates that correspond with the length of the two rectangular sides A and B. The angle alpha is between A and R is the, let's say, the radius of the trigonometric circle. When we look at this, we know that whatever angle we would select, we will see that x1 and y1 will always be between minus r and plus r. And that's the basis for defining sine and cosine. Now let's have a look at the sine at x1. We're first going to define the cosine. I'm sorry I said the sine, but it's the cosine. When we look at x1, x1 is between minus r and plus r. And when we divide both sides by r, we find that x1 divided by r is between minus 1 and plus 1. And we define basically x1 over r as the cosine of alpha of that angle. And that's the definition of the cosine. And here we see A is r cosinus alpha, the element that we found before already. Now, when we look at this, we see the second, or we can define the second element, which is the sine of alpha. And we look at y1. y1 is between minus r and plus r. We divide like we did before by r. And we find that y1 divided by r is between minus 1 and plus 1. The next thing we can define is that y1 over r is equal to sinus alpha, and we find b is r sinus alpha. Now when we look at this again, we have those the same circle, the same triangle. We know that x1 is A and it is equal to r cosinus alpha. This is the projection of r on the x-axis. We see it here. This is r cosinus alpha. Then y1 is B is r sinus alpha. We have the projection of r on the y-axis. And here we find r sinus alpha. When we look at the different quadrants, it's very important to look or to understand what the signs of sinus and cosine are when we are looking at the different quadrants. Here we have in fact the trigonometric circle, and we see different values of alpha in different parts of the quadrant. So we have first alpha, which is between 0 and 90. Then we have alpha between 90 and 180, and we can say it's 180 minus alpha. In the third quadrant, we are between 180 and 270. And in the last quadrant, the fourth quadrant, we are in fact between 270 and 360. Or we can also say that we can call this angle minus alpha. It would give us the same result. When we look at the quadrants, we see in the first quadrant sine and cosine are positive. In the second quadrant, sine is positive and cosine is negative. In the third quadrant, sine is negative and cosine is negative. And in the fourth quadrant, the sine is negative and the cosine is positive. So whenever we know what the value of the angle is, we know in which quadrant it is, and we know that we have either a positive value for sine or cosine or a negative value. Now let's have a look at some basic equation of trigonometry, a very important equation. We have a triangle ABC. We can also say here that c squared is a squared plus b squared, that's Pythagoras. And we say also c is what we called before the radius of the trigonometric circle. Now we know at this moment that r squared is a squared plus b squared. When we divide both sides by r squared, we find that a over r to the square plus b over r to the square is equal to 1. And we also know that a divided by r is cosine, b divided by r is sine. So we can replace those in the formula, and we can say that cosinus square of alpha plus sine square of alpha is equal to 1. And that's the basic equation of trigonometry. It's a very important equation to remember. So we see there the angle alpha, and we can apply this also, of course, for the angle beta. Now, when we look at some values of cosine and sinus alpha, we look at it in degrees and in radians. So we have 0, 30, 45, 60, and 90 degrees. And we look at sine, we start with 0. And then we have, for 30 degrees, square root of 1 over 2. For 45, square root of 2 divided by 2. For 60 degrees, square root of 3 divided by 3. And 90 degrees, square root of 4 divided by 2, which is of course equal to 1. And for the cosine, we have the same in the opposite direction. And that's very interesting to understand how that we can verify those numbers. We also have to remember that cosine and sine are periodic functions with a period of 360 degrees or 2 pi. It means that after repeating the angles for 360 degrees or 2 pi, it means doing one full circle, we start with the same numbers again. So when we look at this, at the function here, we have a nice graph of that. So we see this cosine function which starts from 1, and then we also have the same for the sinus function. So here we can say that cosinus alpha is cosinus alpha plus k times 360, which is equal to alpha plus 2k pi. And in fact, k is an integer, a positive or a negative integer. And we see that the periods go in both directions. We have the same for the sinus function, sinus of alpha. And this is what we typically refer to with the sinus function. This is this nice function that is used in many applications, and of course, which is a beautiful function that we can define. It's also important to understand that we have the same relationship here. So alpha plus k360 or alpha plus 2k. Now, when we look at those two curves, what we have to see is that there is a phase difference. There is a phase difference. In fact, cosine and sine are basically the same functions, but they are shifted over 90 degrees. And we see that this is in fact leading where we see cosine of 0 degrees, which is 1, is equal to sine of 90 degrees. And that's a very interesting property when we look at those different functions. So we could also say that the cosinus function is a sinus function, but with a phase difference of pi over 2. Let's look at some exercises there. First of all, we want to find the cosinus alpha and sinus alpha. We have this rectangular triangle with two sides 5 and 5. And we can find here that r squared is 50. 5 squared plus 5 squared is 25 plus 25 is 50. And r is 5 square root of 2. We know here in this case, specific case, that alpha is equal to beta. And we can say that the cosinus of alpha is 5 divided by 5 square root of 2, which is 1 divided by square root of 2. And when we rationalize the denominator, we find that this is square root of 2 divided by 2. We can do the same thing for the sinus of alpha, and we find exactly the same value because both angles are the same. We can also verify the validity of the formula cosinus square alpha plus sinus square alpha is equal to 1. And we put here the two values of cosine and sine in this equation. So we have square root of 2 divided by 2 plus square root over 2 divided by 2 to the square. Is this equal to 1? So we find 2 divided by 4 plus 2 divided by 4 is in fact equal to 1. Now we have some final exercise you can use using your computer or calculator, which has these functions on it. And I just ask you to stop the video here and do the calculations for cosinus 34 degrees, 127 and 344 degrees, and do the same for the sinus function. So if you want, you can stop the video here and we can see, you can do the calculations and then you can see if you did it correctly or not. So, you did the calculations, so let's have a look at the results. So we have here for cosinus 34, 0.8290, for sinus 34 degrees is 0.5592, and we do the same thing for the others. And we see cosinus 127 in the second quadrant, so it's negative, and the sinus is positive. Cosinus 344 degrees, fourth quadrant, so cosinus is positive and sinus is negative. So that's it for this second video about trigonometry. We're going to use that later when we will be developing some formulas, some special formulas that we will also use in linear algebra. That was it. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.